Game development in x86 assembly. So I think we're getting really close to the end. I don't know if we'll finish Pong in this episode, but I think we're close. I'm gonna go ahead and add the ball. So if we make good progress, we'll do collisions. But the first thing we need in order to have ball is collisions. So we need a ball X. We'll put it in the center of the screen, I think, somewhere around 160. Ball Y. It should be about 100, but I think 90 because we're going to have a ball size, but that'll just be 10 anyways, so I'm thinking that we'll just hard code that. Normally you wouldn't in a different language, but in assembly variables aren't as useful because there's no like object oriented stuff. So we need a DrawBox, but we need a DrawBox that sets up all the parameters beforehand. So we'll go ahead and call it DrawBall because I think it's probably a good idea to have it in its own thing. That way we can look at it and go, okay, this is DrawBall, this is DrawBox. In fact, we could have a clear screen as well, so we might do that, clear screen. There are faster ways to clear the screen than this. I know they've been mentioned by people, but for now, and this is how it's going to be. Okay, draw ball, right. So the EAX, these are like ball X and Y's. So instead of assigning it that way, we need to grab the ball X. So I believe instead of 20, it'd be ball X. Actually, for the SQX, and then this would be ball Y, I think. And then width is 10, height is 10. It's something like that. Aha, we have a ball. And then we need to make the ball move. So to make it move, we just need to do sort of update to X and Y. And this is going to be probably for this scenario, we're going to do a pretty static value of, I think we'll do 2 as the move speed. And then we'll do a direction. So we do need to probably have a variable called ball direction. And that can just be just a byte of 0 or 1. It's only 2 directions are available. So there also needs to be ball up down. So whether or not it's moving up or down. So 2. Well, we need to actually to move in the ball X to this one. And then we need to move EBX 2, which is going to be the speed. And then we need to move, we need to compare ball direct to 0, jump if equal, to dot, and this will be 0 will be add. Okay. Dot add dot sub. So actually we don't need a dot sub because we're just going to do sub underneath. So subtract from EAX, I think. EBX, yeah. And then move ball X. So we need to assign EAX, the result, as the ball X value. And if we're jumping to add, then instead we are doing add EAX. Okay, and then EAX, EBX, add. Okay, we assign, this is just for ball move. Okay, we'll say this is ball move X because I think we'll need to do ball move X and ball move Y separately. Let's see here. So I think what we're going to do we need a done. Because if we do the subtraction, we need to skip over the addition or else it won't work. So now we have draw ball, clear screen. These are the draw paddles. So we probably should do that too. Draw paddles, just to make sure that it's all clear. And draw paddles. And we also need move ball needs to happen no matter what, so we'll put it at the top. So call wait, was it move ball or is it ball move? So move X. Uh-oh, we got an error or something. Operating size not specified, 284. Oh yeah, compare. I believe it's just byte. Aha! It works. But it's going through stuff. So I think what we need to do is check for collision. So that's probably should be the first thing. And that would be CMP oh, you know what? It does depend on the direction the ball's moving, whether or not there's collision. So, but it will work either way. It'll work either way. So it doesn't really matter actually. So CMP, we need to compare the ball X position to to 310 because it's 10 in width. So yeah, so not 320, that's the width of the whole screen. We just need it compared to 310. And then jump if equal to, jump if greater or equal to dot switch direction. So, and then this is update position. So if it isn't, jump dot update position. In switch direction, we need to assign direction. So ball direct, if it is in move X, and so switch direction, we need to specify the direction. So this is if it's too far on the right side. So we'll call it switch direction 0. Yeah. Because 0 is the one we're comparing here. So, and this is compared to that side. So that's the positive direction. So if it's equal to 0, it's going forward towards this value. Okay, switch direction 0 means that we need to move EAX 1, and then we need to move ball direct EAX, and then update position will go regardless, so we don't have to worry about that. But we need a, well, actually, we probably need to copy this for the other one, right? Switch direction 1. And this will go from being 1 to 0. And then we'll need a JMP update position. I don't know if this will work, but we'll find out. Uh-oh, we did something wrong. Oh, it's the compares again, isn't it? Operand size. Compare. Is it a D word? I think it was DD, so I think it's a D word. Label alone without a colon. Oh, am I still doing that? Yeah, I'm still doing that. Aha! Aha! And now it's not going to work because, yep. So now we need another one here. So we need a update position. Actually, isn't the issue here. Okay, D word ball X to 0, and then 1 if it's equal. And then if neither of these have hit, then we jump to dot update position. Okay, so far, oh, that's the error I was worried about. So I did something wrong. So it reaches the end, it goes switch 0 to direction to this, then it goes to update position. It comes back around. Oh, something's triggering where it shouldn't. Oh, I know what it is. I think. So we're comparing it here. If it's greater or equal, we switch the direction. It switches the direction. Update position, add versus subtract. I think it's because we're still Oh, greater than equal. This is needs to be jump if less than or equal. Okay, so that's working. And we're 15 minutes in, so I think that's where I'm going to stop the video here.